Alright, so today we are doing just a day full of proofs dealing with our congruent triangles. I had to stop and think about which unit we were in. Our congruent triangles. So we had our theorems and postulates page. We went ahead and filled in the angles within a triangle add up to be what? 180, good. And my exterior angle is equal to the sum of the two remote interior angles, right? And then we have side, 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 angle, side, angle, side, angle, hypotenuse, length. Did I miss any? Oh, third angle theorem. So if we know two angles and two different triangles are congruent, then that third angle must also be congruent. All right. So let's go ahead and just dive right in with our first proof here. So go ahead and sketch this, copy this proof down on your paper. Give you a moment or two for that. Again, we're doing handwritten notes today. Yeah, go ahead and draw the shape so you can mark on it. Doesn't have to be beautiful and perfect. So you have an idea of what we're working with. Alright, so they give us that x is the midpoint of segment BD, and x is the midpoint of segment AC. Again, as we go through and do proofs, mark what they give you on your picture to help you visualize it, as well as anytime you draw conclusions from, you're going to make sure you state those. Alright, so we have x is midpoint of BD, x is midpoint of AC. Alright, what does that mean if it's the midpoint? What does it mean to be the midpoint? Go ahead, Anthony.
Both sides are that's like an exact.
Yeah, it's an exact one. We have two congruent halves, right? So let's go ahead and actually translate this. Let's mark it on our diagram and then translate what that means to be midpoint. So it's the midpoint of BD. Would you agree that these two segments are congruent? Because x is just this intersection here, where our markings are from point to point. And then we have these two are congruent. Okay? So let's go ahead and translate that, state that what we know from the fact there that it is the midpoint. So we have XD is congruent to BX, and we have CX is congruent to XA. Notice they're not necessarily congruent to each other, but that those two sets are congruent. And what would be my reasoning for that? Good. Definition of midpoint. We translated what it meant to be a midpoint by using that definition. Alright, so there's nothing more that we can really translate from our midpoint there, so let's take a look at what we're trying to accomplish here. We want to show, let's see, triangle DXC is congruent to triangle BXA. Oh, this one's way too easy. We already have two pieces, right? We already have two sets of sides congruent. What method do you think we could use here? Vincent?
Side angle side.
Very good. We can see pretty easily that I have these vertical angles are congruent, and then we'd have side angle side. So let's go ahead and just formally write that out. Now, we do have to be careful when we write that these angles are congruent to each other. Can I call this angle X? No, there are way too many angles happening there for me to know what you mean by angle X. So we do have to use three letters. So angle DXC is congruent to angle AXB. And again, we know that by the vertical angles there. So again, we have to use the three letters. It doesn't matter the order as long as X is in the middle there. Right? And now let's go ahead and state that our triangles are congruent. So triangle DXC is congruent to triangle BXA. And notice that DX and BX go together. So we go DXC, BXA. What's my reasoning here? Good. Side angle side. And again, technically that's a theorem, but I don't. It's fine if you don't write it. Don't be too picky with that. Okay, questions on this first one? Not too bad. Uses just a straightforward side angle side. All right. Let's go and take a look at our next one. I'll give you a moment to copy this down. So we have AD bisects BE, and AB is parallel to D. Right, so we have segment AD bisects segment BE. AB is parallel to segment D. Alright, what does that mean if segment AD bisects segment BE? Vincent.
It cuts it into two congruent parts.
Good, it cuts into two congruent parts. So it operates the same as the midpoint, but instead of them saying C is a midpoint, it says that AD cuts it in half. Good. So let's go ahead and mark that on our diagram and translate that. So we know that segment AC is congruent to segment CD. Segment AC is congruent to segment CD. Talk to your shoulder partner real quick. What do you think the reason for that is? Share with your shoulder partner what you think the reason is. Favorite question. Where you want to go?
Isn't it supposed to be the other lines that are in the...
Oh, did I do the wrong ones? Oh, thank you. I read the wrong ones, guys. Sorry. Thank you. Alright, what is our reasoning? What do we think it is? Come on, I heard you guys talking. What do we think it is? I'll make you feel more comfortable. Definition of, if we have a segment bisecting a segment, does anyone remember what we call that? Close, close. Definition of segment bisector. The segment got bisected, right? Bisect segment. So definition of segment bisector. Anyone have their shoulder partner say that to them? Good work. Good work. All right. Now, our other piece we have is that AB is parallel to DE. They've gone ahead and drawn that on the picture. I want you now to go ahead and try filling in the rest of this group. Work with your shoulder partner. How can we go ahead and prove that triangle ABC is congruent to triangle DEC? Yeah. They're the same length. Yeah. If you just a quick counterexample would be parallel. So let's just go and do segments. I can switch this guy down to just so there are two parallel segments on this. Alright, how many steps do we think it takes? I like the sound of that. 5. Alright. Now Anthony asked a good question that I want to make sure we all understand. If two lines are parallel, or two line segments are parallel, does that mean those line segments are congruent? No. We do not know that these are congruent based upon the fact that they are parallel. Here's an example of two parallel segments, and they're definitely not the same length. Okay, so just be careful. Parallel does not tell me about length. All right. What do we do for step 3? Vincent?
Angle ECB is congruent to angle CACB by the vertical angle theorem.
Good. So we have angle ECB is congruent to angle ACB by vertical angles theorem. Good. Raise your hand if you had that for step 3. Raise your hand if you did something else for step 3. Perfect. Ryan, what did you do for step 3 instead? Okay.
Angle CAB is congruent to angle CD, and in the same step, the angle CED is congruent to angle CBA.
Raise your hand if you used that with your next step. No one? Well, very good, Ryan. What was your reasoning for that?
Alternate interior angles.
Good. So you could have done vertical angles theorem next, or you could have done alternate interior angles theorem. So I'm going to label them both as step 3 because it could have gone either way, just so you guys know for your notes. And vertical angles theorem, so if we would have done, let me go erase this real quick. If I would have done just alternate interior angles theorem, do I have enough information to prove those triangles are congruent? Yeah, angle, angle, side, right? So I could have done just alternate interior angles and then had angle, angle, side. So did you only take 4 steps? Awesome. So you could have done it that way. If you did your vertical angles theorem, then you didn't need both of these. You could have, if you would have used this set, we would have proven our triangles congruent by what? Angle, angle, side. And then if I would have used the other way, if I would have used my other set, what would have been my reasoning here? Angle, side, angle. So this is an example where we might have slightly different routes to prove it, and that's perfectly fine. On your quizzes and tests, I look through your steps. I actually read your proofs to make sure that yours follows logically. So if you use vertical angles theorem in one of your alternate interior angles and got it by angle, side, angle, do it opposite. If you use the other set and did it by angle, angle, side, that's perfectly fine as well. There's no one way that's better than the other. Probably the way that Ryan did it might have been the fastest in terms of steps, but you still had to write quite a bit for it. So I'm going to go ahead, I'll just stick with what I have sitting up here. So we have angle CED is congruent to angle ABC. And that was by alternate interior angles there. And then finally I can go ahead and state my last thing, that the triangles are congruent. And again, make sure you match this proved statement. Triangle ABC is congruent to triangle DEC. Oops. And that was by, for this one, angle, side, angle. Alright, now please, 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 when you do a proof on your quizzes and tests, if you use angle, side, angle, do a double check that above here you actually listed 2 sets of angles congruent and a set of sides congruent. So many times I have students that say angle, side, angle, but they've only showed 2 of the 3 pieces. You must have all 3 pieces shown before you can do that. Alright, any questions on this?
Could you have said angle E and B because there's only that letter?
Yes, that's a good point there. For this particular case, E and B you could have said here instead. Angle E is congruent to angle E. And likewise A and D as well. Angle C is the one where we have to use 3 letters. Very good question. Other questions with this? Alright, go ahead and copy this picture down. Alright, so this is a different type of problem in that instead of asking for us to prove two triangles congruent, they're asking us to prove that AM bisects BAC. So they're not asking us to prove triangles are congruent, but we can use congruent triangles to help us show that. So let's go and kind of translate here. AM bisects BAC. What does that mean if a segment is bisecting an angle? What would that translate to for us? Good. So it would be that AM is bisecting an angle BAC, so it would split those into two different parts. That's what we're wanting to show. So we're wanting to show that in order to then lay claim to the fact that it bisects. Okay, so we need to show that those two angles are the same in order to make that proof statement there. Alright, so what we're going to be doing here is we want to first show these two triangles are congruent, and then use CPCTC to show the pieces are congruent. Alright, let's go ahead and mark on our diagram and translate. So we've got AB is congruent to AC. And then we have N is the midpoint of segment BC. And we talked about in an earlier problem how that means that two pieces are congruent. So let's go ahead and translate that midpoint piece there. There's nothing really translate with the two statements congruent. So let's translate the midpoint. So we have segment BN is congruent to segment MC. And what would be my reasoning here? Good definition of midpoint. We're saying midpoint because they said. Alright. What else do we know?
AM is congruent to itself.
Very good. AM is congruent to itself. So we don't necessarily know anything else about the angles right now. Even though this looks perpendicular, right now I cannot claim that it is perpendicular. But we do know that AM is congruent to itself. Let's see if we can remember what's this property? Reflexive. Alright, and now what do you guys think we can do from here? Go ahead.
State the triangles are congruent.
Very good. So now I can go ahead and say that these two triangles are congruent. Alright, go ahead and write out that congruency statement. The two triangles are congruent and your reason for it. Alright, and let's see how we did in writing out our congruency statement. Again, you might have your letters in a different order. That's fine, just make sure the proper letters match up. So I'm going to say triangle BNA. Alright, so look at your statement. What do you have matching up with B?
C.
Good. What do you have matching up with M? And matching up with A?
Okay.
So yours might be in a different order. You might have MAB and MAC. That's fine. But as long as we have that same pairing. Okay, what was my reasoning here? Good. Side. Alright. So now we have shown the triangles are congruent. Okay, so now's our time to pull out CPCTC. So don't forget CPCTC. And who can tell me what that means for me? What does that translate to for us? Talk now?
Triangles are congruent.
Good. So if I have two triangles are congruent, I can know all of their corresponding pieces are congruent. So if those corresponding pieces of congruent triangles are congruent, I think, is that on your, so on your theorems and approximate page, don't write that at the bottom there. CPCTC, corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. We can only use CPCTC after I have established triangles are congruent. Okay, I can't use it if I don't know the triangles are congruent. So now that I've shown these two triangles are congruent, we can identify any of the congruent pieces that we want. But we're only interested in a particular one. We want to show that AM bisects BAC. And we said that means we want to show that these are congruent. Now that I have the triangles are congruent, now I can say their corresponding pieces are congruent. So we're going to go ahead and state that next. Alright, so again we have to use 3 letters. Angle BAM is congruent to angle CAN. So again, I'm just stating that these are congruent. And my reasoning is CPCTC. And you can just write that out. And again, we can state this because I have triangles congruent, and I can say some other pieces. Alright, questions so far? Okay, what do you think our next step is? Andy?
AM isosceles angle BAC.
Very good. We can now go ahead and claim that proof statement. So we have segment AM bisects angle BAC. Because again, we know that if it's bisecting it, the two pieces are congruent. So we've shown the two pieces are congruent, which means it is bisecting it. I think they know what the reason is. Right? Perfect. Awesome. Definition of angle bisector. Very good. Angle bisector. Questions on that one? You guys seem to be doing pretty well with this. I'm going to let you try this next one completely on your own. Alright, so draw this picture. Don't be alarmed that we have a circle there. It's just, it actually doesn't make any difference for everybody, or for our group. We'll be learning about this. Circles come in unit 9, I think. It's either 9 or 10. And we're actually going to learn that what we have here, this is a chord. If you have a radius and a chord intersect, then you can have them intersect in a perpendicular area. We have MO and PO are radii. And we're going to learn all kinds of pieces about circles, but that's in the springtime when we have had snow days, hopefully, and have them. Alright, so again, once you've got this done, go ahead and try this. Feel free to work with your shoulder partner. Be careful, make sure you don't skip steps. Isn't it so satisfying when you do? Again, feel free to talk to your shoulder partner. It took me 6 steps. That gives you an indication. Give you about 2 more minutes to give that a go. Once you think you have it, go and check with your shoulder partner, someone in front or behind you, see how your proofs compare. Alright, I put up the first few steps here. So step 1 is just our given. Now 2 and 3, I'm just simply translating my given information. NO bisects angle PON means I have those 2 individual angles here are congruent. That's my definition of angle bisector. Check to make sure you have that. You must have that. So again, we're just translating that given information. Now here's the other piece that I'm curious to see if we got this. NO is perpendicular to NP. Definition of perpendicular lines simply tells me that perpendicular lines are two lines that meet at 4 right angles, or intersect at right angles. So the fact that they're perpendicular allows me to state that angle MNO and PNO are right angles, okay? Raise your hand if you had step 3 somewhere within your proof. Good, okay, so that's a necessary part here. Questions so far? All right, Matthew, what was another piece that we have for this? What else can I say for my picture? Ryan, go and help him out since you're water back there.
Well, the next step is angle MNO is congruent to angle PNO.
Good, so we need to have that those two angles are congruent. Because right now, I only have shown one angle is congruent. So I know that right angles are congruent. I hope you know that right angles are congruent, but you've got to show me that you know that. So we need to go ahead and state that angle MNO is congruent to angle PNO. And, ooh, what is my reasoning here, Samantha?
Right angle congruence theorem.
Very good, right angle congruence theorem. You could have also just said all right angles are congruent, because that's all the right angle congruence theorem says. I feel like the title is just wrong with the theorem itself. Good. Raise your hand if you remember to do that, to have your right angles congruent. Awesome, awesome. Okay, now what's my last piece that I need to show those triangles are congruent? Anthony?
MNO is congruent to NO.
Very good. NO is congruent to itself. So even if we miss the right angles, raise your hand if you at least got the reflexives too. Very good. Okay. So NO is congruent to itself. And my reasoning is reflexive property. And so now I can go ahead and state that proof statement that triangle MNO is congruent to triangle PNO. And angle side angle. Any questions on that? Anybody get that completely right? Good. Good. Okay. Let's see, I think I've got this next one for us, and then we're going to talk about isosceles triangles. Let me make sure this is the one that I want. Yeah. Okay. Nope. That. What's that other one? Don't draw that. Ooh. No. Alright. This is the one I want you to try next on your own. We've got some sets of perpendicular lines. We also have a set of congruent statements here. I'll go and write this out a little bit bigger for those of you that are at the back there. Actually, I think I can zoom in. Okay. So go ahead and copy down this information in this picture. Actually, let me fix this. Okay, copy down this picture, this information. Again, be mindful of the fact they give us perpendicular lines. So it shouldn't be too bad for us. And then go ahead and give it a try. So copy down and give it a try. Again, you can work with the shoulder partner if you want. Probably not. That's a good question. Trying to figure out for spacing. We might have one or two more after this. Good morning. Okay. You're welcome to sit wherever you would like to. All right, I want you to pause where you are and compare what you have so far with your shoulder partner. Even if you're not done, compare what you have so far. If you don't have a shoulder partner, turn around or grab another shoulder partner. All right, let's go and see how we have done this. All right. A lot of given information here. So we have VR is perpendicular to RS. We have UT is perpendicular to SU, and RS is congruent to US. A lot of information there. So let's go ahead and translate some of this. Make sure it's all marked on our diagram. So we have VR is perpendicular to RS. We have UT. UT is perpendicular to SU. And we have RS is congruent to US. Okay, so we have perpendicular lines. Let's go ahead and translate those perpendicular lines because we want to show VR and TU. We want to show these two pieces are congruent. Well, those are just two pieces of two triangles. That looks like we might go proof congruent. So again, we have perpendicular lines. Let's translate that. We know we have to translate a couple things with it. If they are perpendicular lines, we can go and talk about the fact that they meet at right angles. So I can say angle R and angle U are right angles. Notice I can use just the one single letter here because that is the only angle with it. What's my reasoning for this? Good definition of perpendicular lines, just like we did before. All right, but it's not enough just to say that they're right angles. We need to make sure that we state they are congruent. Angle R is congruent to angle U. You're probably going to have some type of proof like this where you're going to need to translate that perpendicular lines. Make sure you don't forget those steps here. All Alright, so those two angles are congruent. We said that's right angle congruence theorem, or all right angles are congruent. Either way, you can write it. I use the type a lot. Okay, so now we can see we have a set of sides congruent. We have a set of angles congruent. So we've got these two different pieces here. What else do I have? Go ahead, Swap.
Angle BSR is congruent to angle TSR.
Very good. And notice how he used the 3 letters there. So angle BSR is congruent to angle TSU. And what is my reasoning for that? How do we do that? Go ahead. And vertical angles theorem. Raise your hand if you use vertical angles theorem. Keep your hand up if you had both parts of the perpendicular lines. Ooh, very good, very good. Okay, so now we have this. What can I state now?
Triangle BRS is congruent to triangle TUS.
Very good. We can go and say those two triangles are congruent. Triangle VRS is congruent to triangle, you said TUS? Good. And again, you might have a different order. Just make sure V and T go together, are U and S and S. And what is my reasoning for that one? How do I know that these two triangles are good? Good, angle setting. Alright, now don't stop and think that you're done just because you proved two triangles are congruent. We want to show those pieces are congruent. So now that I know the two triangles are congruent, now I can say those pieces are congruent. So now I can say VR segment is congruent to segment TU. And what is my reasoning here? Go ahead. My favorite reasoning of all geometry, CPCTC. Now we're done. Raise your hand if it took you 6 steps and you did that. Awesome. Okay. Those of us that we're not raising our hand very often on getting our steps, do we have questions on this? Where we were stepped into? Good? Okay. So far, show me how you're feeling with our proofs of congruent triangles. Thumbs up, thumbs middle, thumbs down. Alright. Okay, so let's do, we're going to do a little bit more of it, but I want to first talk about isosceles triangles. So on your theorems and postulates page, here's a sneak preview as to what we're learning next class. We're going to go and talk about the theorems today and apply them to solve problems next class. So I'm going to go and pull it up here. All right, so we've already filled in this top half, our warm-up, and the bottom piece here. So now let's talk about isosceles base angles theorem and the converse of the isosceles base angles theorem. All right, now we know specifics about isosceles triangles. What is an isosceles triangle? You guys really don't like that. What is an isosceles triangle? Good, a triangle where we have 2 sides are congruent. Okay. And we said actually it's at least 2 sides are congruent, but if we have more than that, we're just going to go call equal. Okay. Now we also drew on our papers, I think it was a couple classes ago, kind of the pieces of an isosceles triangle. So real quick, let's go ahead and just draw another quick example of that. So I have an isosceles triangle. What do I call these guys, the ones that are congruent? Legs. Good. And this is not a hypotenuse, but rather what? Base. Good. And we said this is our vertex angle. This here is my actual vertex. And we said that these are base angles. I think we read that on the worksheet 1 or 2 or something. Okay. So we know it's an isosceles triangle, 2 sides are congruent. Alright, our isosceles base angles theorem. I like this one because the title kind of gives us a clue as to what we're talking about here. Alright, so our isosceles base angles theorem, we're talking about these 2 angles here. Any thoughts as to what our theorem might be saying about those two angles? Anthony?
Base angles are congruent.
Actually, let's just go with the fact that the base angles are congruent. So if we have this isosceles triangle, we know it's isosceles, then we have that the base angles are congruent. Okay, so isosceles base angles theorem. Let me make sure I word it correctly. So it's going to sound kind of funny, but it's fine. If two sides of a triangle are congruent, two sides of a triangle are congruent, so as we see in our isosceles picture, those are your legs, then the angles opposite those sides are congruent. The angles opposite those sides are congruent. I feel like this is a super generic way of saying in an isosceles triangle, base angles are congruent. The reason why they make it generic is because if I had that equilateral triangle, wouldn't this still hold true? Because in an equilateral triangle, let's say it's those two. Well, we know all three of them, right? So if these two sides are congruent, then those two angles must be congruent. If these two sides are congruent, then the angles opposite must be congruent, and thus we have all three angles. So that's why it's kind of generic. So the isosceles base angles theorem basically tells us in an isosceles triangle, base angles are congruent. Now the converse of this is also true. So remember, converse just means we flip-flop, right? So if two angles of a triangle are congruent, right, so now we're starting off with the angles are congruent. Then, just the converse. The sides opposite those angles are congruent. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So really it's saying if we know our base angles are congruent, then we can say the sides, the legs are congruent. So isosceles base angles theorem by itself says if it's isosceles triangle, then the base angles are congruent. The converse says if I have base angles congruent, I can say it's isosceles, these two sides are congruent. Questions with that? It kind of seems obvious, but it's a theorem that we will actually use and can be helpful. So when we were going over worksheet 2, we had some problems where I apologize and said, I'm sorry, I used something we hadn't learned yet. This is what I was using. If I had two triangles, say, if I had these two triangles where, don't want that. Let's overlap it actually. I think we had a problem somewhere that was kind of like that. Where if we were given that this was isosceles like that, then I could go ahead and use the isosceles base angles theorem to state that those be congruent as well. And that could help me sometimes get additional information about certain triangles. So I used that a little bit on that worksheet too. That's why some of those answers I said you might not have had the same thing. But let's go ahead and take a look at a proof that would involve using this. And your homework will involve using these theorems in terms of proofs. Next class, we'll use these theorems just to solve for unknown values. All right, let me go ahead and find the proper one. Make sure I pull up the correct one for you. This one here. So go ahead and copy down this proof. Put this picture. And this will be our last for today. So we have NQ is congruent to PQ, as well as angle 1 is congruent to angle 2. Alright, so here we have overlapping triangles. They want us to show that segment MN is congruent to segment PO. So if I could show that these overlapping triangles are congruent, then I could then use CP. Alright, so MQ is congruent to PQ. MQ is congruent to PQ. I'm going to go and fill that in. And then angle 1 is congruent to angle 2. Alright. Now, what we just learned was our isosceles base angles theorem and converse of it. So here we see we have two angles congruent. So by the converse, I can say those sides opposite are congruent. So I can go ahead and make this notation by the fact that the sides opposite are congruent. So I can go ahead and say segment QN is congruent to segment PQ. Nope. QO, right? Segment QN and segment QO. And my reasoning would be converse of isosceles based angles theorem. Okay, so again, we have the angles, we can know the sides are congruent by the converse. Questions on what we've done so far? Okay. Now we've got to be pretty careful with what we do here because we're not trying to show that these well, we could show that the bow ties are congruent, right? Or we could show the overlapping ones are congruent, because we want to just specifically show, we just want to show that MN and PO are congruent, right? I was going to head for the overlapping triangles, but we could even just use the bow tie triangles there. So what additional information do I know on my picture here to help us out? Go ahead, Georgia.
Angle NQN is congruent to angle OQP.
Very good, very good. We can see that sneaks up over and over and over again. Angle MQN is congruent to angle PQO. And what is my reasoning there? Go ahead.
Vertical angles theorem.
Good, vertical angles theorem. Very good. Alright, so now if I look at these triangles, those bow tie triangles, then I can say those two triangles are congruent by side and side. So let's go and do that next. So I have triangle NQN is congruent to triangle PQO. Let's make sure we got that right. MQNPQO. What? By side angle side. And then now I can finally make my proof statement. Segment MN is congruent to segment PO. And my reasoning for that would be CPCTC. Alright, so that's kind of the way that we could use that. We could have gone down the road of showing the overlapping triangles congruent, but we would have had to say reflexive property with NO, as well as segment addition postulate with MQ and QO. So definitely easier to do those triangles. Any questions with that? Your homework for tonight, you'll notice on your assignment sheet is worksheet 5 and 6. I'm going to pass out 5 first. I'll pass it. Alright, now worksheet 6 is coming. Alright, so you should have worksheet 5 and worksheet 6 proofs. 6 says to complete on a separate sheet of paper. A couple of them you might need to if there's not enough room, but some of them you could fit right on there. So both of these are your homework. You got about, 10 proofs. And tomorrow to Stinger 1 we are going to bring what? The forms. Signed, dated, and filled out.